will revise the content you have learned in last lecture. Okay, so in last lecture, student, let me see what is written in chat box. Okay, so in last lecture you have studied signal flow graph. From signal flow graph, I have taken one example. Here you have calculated the gain, that is nothing but transfer function for SFG by using Mason's gain formula. So this is the equation, this is the example I have taken. Okay, you have written the equation for loops L1, L2, L3 and L4. Then you have written the equation for path P1 and P2. Then equation for pair of non-touching loop, that is L1, L3, L1, L4 and L2, L3 and L2, L4. And by using this equation, Mason gains formula, you have calculated or you have simplified this equation and you got the transfer function of signal flow graph. So this is the transfer function. Ys is nothing but y of s is output, r of s is input. So this is the equation. Now this is nothing but your transfer function for this SHG, right? So that you have studied. Now I'm going to take today 3-4 examples. Okay, so students, you are supposed to write, you are supposed to draw this block diagram. Okay, so this is the example I am going to take now related to block diagram reduction. So this is the given block diagram. Just wait, admitting student. 6. So please draw the block diagram, students. If you are having notebook with you, draw the block diagram and let me know after finishing. So today you are going to solve the example related to block diagram reduction techniques. By using block diagram reduction technique, you are going to solve this example. So this is the given block diagram. Now by using rule number 1, 2, 3, 4, 5 up to 9. So you can use all these rules, okay, to reduce this block diagram with simple one. Just wait, admitting student. Finish? Now see, all should be here. Now I'm going to explain the block diagram. This is the given block diagram to you. And you are going to reduce this block diagram into simple block diagram. That means simpler one means only one block will be there. Okay, with transfer function, with input and output. That's it. So we are going to reduce this complicated block diagram by using block diagram reduction technique or rules. You are going to transfer this block diagram into simple block diagram. That simple diagram, block diagram, will be consisting of only one block with transfer function along with output and input. That's it. Okay. Now observe the block diagram carefully. Observe the block diagram carefully. Now in this block diagram, this is nothing but your summing point. Are you with me, students? Have you drawn the block diagram?
Yes.
Okay, yes. Varat, thank you, beta.
Yes, ma'am.
Thank you, Sanskar. So observe the block diagram carefully. Now this is nothing but R of S is nothing but input, Y of S is nothing but output. Okay. Now this is nothing but your summing point. First summing point, then second summing point. Then this block is nothing but one process with transfer function G1. Okay. Now this is nothing but again summing point. This is the block of process with transfer function G2. Now this is the block of process with transfer function G3. Okay. Now coming to this block. This is the block of feedback element. So inside this block, feedback element is present. And what is transfer function of feedback element? That is equal to H1. Now coming to this block again. This is again connected in feedback loop. So this is feedback element with transfer function H2. Okay. and here you will get output. आता बघा. Now observe it carefully. So this is one loop. बघा मी trace out करते की loop कुठे आहे आपला. So this is nothing but one loop consisting of G1, G3, H2 up to this. This is one loop, feedback loop, closed loop control system, right? Now coming to this, if you are going to use first technique of block reduction, first rule, that is multiplication of G2 and G3, okay? That will become one block. So this is closed loop control system. Now, if you are going to multiply G2 with G3, this connection will be connected over here, okay? So you will get one loop, okay? Reduction, first block काय असणार आपला reductionचा या दोघांची multiplication, okay? नंतर second block, आपली diagram कशी होणार आहे नंतर? This loop becomes as it is. Instead of two block, you are going to write one block. Inside that block, you are going to write transfer function G2 into G3. हा point कुठे connect असेल त्यावेळेला? इथे connect असेल, right? So at that time, you will get second closed loop. So that closed loop is nothing but from this point. If you are going to connect over here, this line. So this is second loop. Ha second loop होणार तुमचा, right? Now you are going to write equation for second loop by using again block diagram reduction technique. आता third loop चं बघा. Third loop मध्ये हे सगळं reduce होत काय येणार आहे? Third loop तुमचा इथून आहे बघा. हा this is nothing but your third loop. Third loop, right? This is again closed loop control system. So you are going to write one transfer function for all these blocks. And this is how you are going to reduce this complicated block diagram into simpler one with input and output only, right? Now, next step, solution. Students, please write solution. Are you with me, students?
Yes, ma'am.
Yes, ma'am.
Okay. तुम्ही ड्रॉ केलंय का मुलांना ड्रॉ करायचंय हा चला सोल्युशन बघा बरं करता येत आहे का तुम्हाला just a second, I'm waiting student. Now write solution. Next. Just I have explained. So what I have done, I have multiplied G2 with G3 and I have written that transfer function G2 into G3 in one block. Now your diagram is straightforward. You are having three closed loops. Okay, so this is one loop. You are going to transfer this loop into transfer function, right? So you can write this transfer function as it is minus sign over here at some point. You can write, yes, G2 into G3 divided by 1 plus, hey minus आहे तर 1 plus G2 into G3 into H2, right? Yes, are you with me? R is input,
Yes,
C is
ma'am.
output. Okay, beta. Oh my, thank you. Now, when I'm going to draw a line over here, I have to divide by this G3, H1 divided by G3. इथे एक rule लावलाय आपण आणि इथे एक rule लावलाय, right? Now, next step. Please draw the diagram. We have reduced. First step. G1, G2 and 2, G3 केलं आपण. Second step, H1 divided by G3. पुढे जाऊया. Understood? How I have drawn this diagram? Got my point?
Ma'am, can you please repeat?
So this is your diagram. See, this is your diagram, right? Given diagram. And you are going to reduce. Snehal, noise is coming from your side, please. Okay, so this is complicated diagram. Okay, so here you can write instead of G2 and G3 by using first rule. If two blocks of process are connected in series, you can replace this G2 and G3 by one block with multiplication of transfer function. So I have written G2 into G3 in one block, right? And when I'm going to transfer this point, this takeoff point at this point, okay? So what I have to do? I have to take this G3 divided by this H1 divided by G3. बघा
मॅम
rules
बट ते
बघा.
G2 G3 सिरीज मध्ये नाही आहे ना.
हो ना, मग मी काय केलंय हा पॉइंट जो आहे माझा, हा पॉइंट मी शिफ्ट केलाय ना, इथे शिफ्ट केलाय मी आफ्टर G3. So I have shifted my point, this point over here after G3.
Yes,
At that time, what I have to do? I have to divide by G3 to this transfer function. So I have taken H1 divided by G3. बरोबर? आता दोन्ही
Yes,
पॉइंट
ma'am.
सेरीज मध्ये आले ना सेरीज मध्ये, राइट?
Yes, ma'am.
हाँ. Now you can multiply G2 and G3 one block, and by using these two rules I have drawn this diagram. Got it? So I have divided by G3. I have shifted my point after G3. After G3, this point is after G3. So I have divided H1 by G3. Now G2 and yes, please, roll number 66. Any doubt?
Yes, ma'am. Though why is H1 not connected after G2, G3? After combining of G2, G3, like the forward part? Why is it connected to the feedback part?
H1 is feedback element. Hence it is connected in
Yes, ma'am.
feedback
Can we
part.
connect it after G2, G3?
No. H1 and H2 are transfer function of feedback element. So that should be connected in feedback path only. G1, G2, G3
So
are transfer functions of process.
The feedback is for the output of G3, right?
See, this is the complicated diagram given to you. You are going to reduce this into simpler one. This is the diagram given in example. You are going to use all these rules of block diagram reduction techniques from rule number 1 to rule number 9. By using all these rules, you are going to reduce this complicated diagram into simpler one. So go step by step. So H1 is always connected in feedback path, H1, H2, H3, whatever it may be. G1, G2, G3, they are process block. So they are connected like this. Okay. Proceed further.
Yes, ma'am.
And G3 are in series. So multiplication of G2 and G3 is done. And I have written this transfer function in one block. Now observe the diagram carefully. You will get 3 loops only. Okay. This is first loop. This is second loop. Barabar? And this one is third loop. Barabar? 3 summing point, 3 transfer function, and transfer function of process, and 2 transfer function of feedback element. Here there is no any feedback element at that time. What you have to do? You have to multiply with 1. इथे काय येणार आहे? ट्रान्सफर फंक्शन काय असणार आहे? 1. बरोबर? That is one of the rule. So student, keep in mind, you have to revise, you have to remember the block diagram reduction rules while reducing this block diagram. So that rule should be in front of you. ठीक है? चला पुढे जाऊया. Up to this point, any difficulty? Understood? No. Okay, Bharat. चला पुढे जाऊया. आता. Now I'm going to concentrate on this loop. Straightforward loop आहे बघा हा. So for this closed loop control system, I'm going to write equation for transfer function in terms of transfer function of process, in terms of transfer function of feedback element. आता अशी ज्यावेळेस आपली कंडिशन असेल, लास्ट रूल बघा, एकदम लास्ट ब्लॉक डायग्राम रिडक्शन टेक्निक मधला रूल नंबर 9. Rule number 9 is exactly like this. Okay. So you can write transfer function for this is equal to G2 into G3 divided by 1 इथे मायनस आहे तर आपण प्लस लिहिणार आहोत 1 प्लस G2 into G3 into H2. Yes, are you with me? By using rule number 9. Okay, so I'm going to transfer this block diagram like this. Okay, is it visible? Student, is the block diagram visible to
Yes,
you?
ma'am.
Okay, beta.
Visible.
Okay, Bharat. Thank you, beta. So I have written this. माझा लूप एका ब्लॉक मध्ये आला पूर्ण. क्लोज लूप मी कसा ट्रान्सफर केला?
Yes,
By
ma'am.
using just one transfer function. So G2 into G3 divided by 1 plus. Plus का घेतलं मी? कारण feedback signal minus sign ने आहे, right? So I have written over here 1 plus by using rule number 9. Block diagram reduction rule or technique, rule number 9. So G2 into G3 divided by 1 plus.
Ma'am.
हाँ बोल बेटा 1 plus G2 G3 into H2.
फीडबॅक सिग्नल जर मायनस असला असता प्लस असला असता तर
Minus घेतलं असतं 1 minus. So we have derived this equation. We have derived already this equation by using rule number 9. Last rule आहे बघा ब्लॉक डायग्राम टेक्निक्स मधला. ब्लॉक डायग्राम रिडक्शन टेक्निक्स मधला हा शेवटचा रूल आहे. रूल नंबर 9. तिथे मायनस असेल तर इथे प्लस येत आहे. We have derived this equation already. Please try to remember. If feedback signal is plus, you have to write 1 minus G2 G3 H2. Got the answer, Abhishek?
मॅम बट तिथे जर प्लस असलं असतं तर मॅडम
अरे बेटा तिथे जर प्लस असतं तर इथे 1 मायनस लिहिलं असतं आपण.
ओके थँक्यू
1 minus G2 G3 and H2. हे बघा अभिषेक आपण हे जे इक्वेशन आहे ना हे डिराइव्ह केलंय आपण while studying ब्लॉक डायग्राम. दोन्ही पण प्लस असेल तर काय असेल मायनस असेल तर काय असेल हे डिराइव्ह केलंय आपण ऑलरेडी. ठीक आहे मुलांना? So up to this point, any doubt? Understood?
येस मॅम
Okay, beta Pratham. Thank you, Aman. Now, आता बघा. Now this is again G1 and this block is in series. Are you with me? So this block and this block are in series. Okay. So you can write one transfer function instead of this two block. So you can draw one block with transfer function. Just multiply this G1 with this term. So G1 into G2 into G3 divided by 1 plus G2 G3 H2 is the transfer function within one block. Okay. Again, you will get feedback loop. Again, you are going to write equation like this. So next reduction is like this. So I have written G1, G2, G3 just multiplied by G1. Okay, because both the blocks are in series. So multiplication with G1. So I got this transfer function within one block. Now this is nothing but your closed loop, right? Control system. So again by using rule number 9, you can reduce this block. Now how to write equation? बघा feedback signal जो आहे तो काय आहे H1 divided by G3 and with positive sign. Now you can write the transfer function equation 1 minus. Abhishek, are you with me? Your point is coming now.
येस मॅम
आता बघा इथे प्लस आहे बघा. Input signal is plus. Feedback signal is again having plus sign. Now you can write transfer function within one block. Instead of this control system, closed loop control system, you can write one block only with transfer function G2 G3 G1 or G1 G2 G3. Okay, divided by G1 G2 G3 divided by 1 plus G2 G3 H2 divided by 1 minus इथे प्लस आहे आता 1 divided by 1 minus का all this term into this term. So do it theoretically and let me know what is transfer function. Again I am repeating. Yes, got your point. Again I am repeating. Now this is nothing but your closed loop. Okay, closed loop form झाला. Feedback signal is having plus sign. So you can write similar to previous step. You can write transfer function for closed loop with positive sign feedback signal. So you can write like this. This block as it is divided by 1. इथे plus आहे तर 1 minus येईल आपलं 1 minus this block, okay, into this block. Now do it theoretically. बघा करून बघा आणि सांगा मला काय आहे ते इक्वेशन. Yes, anybody got it? Got the equation? थोडं सिम्प्लिफाय करून सांगा मला काय आहे ते इक्वेशन. Yes, anybody? Please simplify. Student, you are supposed to write this equation. Please write G2, G3, G1, G2, G3 divided by 1 plus G2, G3, H2 divided by 1 minus G1, G2, G3 divided by 1 plus G2, G3, H2 into H1 divided by G3. G3 cancel
Ma'am,
होईल. हाँ बोल बेटा.
are you showing that on screen, ma'am?
You are having the simplified equation.
नाही मॅम, तुम्ही आता दाखवताय का ते इक्वेशन तुम्ही जे सांगत होता ते? कारण स्क्रीनवर लास्ट स्लाइड दिसत आहे.
हो, मी लास्ट स्लाइडच दिसते. माझं पुढची स्लाइड जी आहे ती डायरेक्ट माझं इक्वेशन आहे, सिम्प्लिफाइड इक्वेशन.
ओके मॅम, ओके.
Okay, now this is for your reference, student. You are supposed to do this. So by using rule number 9 from block diagram reduction technique, so I got this equation G1, G2, G3, right, divided by 1 minus, after simplification, आता मी तुम्हाला जे equation सांगितलं, I have simplified that and I got this equation. Okay, G1, G2, G3 divided by 1 minus, कारण positive feedback signal होता, so 1 minus G1, G2, G3, G3 cancel झाला into H1 plus G2, G3 into H2. So this is the equation. Simplified equation. आता बघा, this is again closed loop. There is no any feedback element. Okay, so we are going to consider in feedback path what is transfer function 1, right? So again by using rule number 9 you can write this equation. This is the transfer function of process, okay, divided by 1, इथे minus आहे, plus this term into 1. Simplify. You'll get this equation. G1, G2, G3 divided by 1 minus G1, G2, H1 plus G2, G3, H2 plus G1, G2, G3 into 1 आहे कारण, म्हणून G1, G2, G3 again with input R of S and output C of S. So this is the simple block diagram you are having from complicated block diagram. So this is how you can reduce the complicated block diagram into simpler one by using block diagram reduction techniques. Got it? Understood?
Yes, ma'am.
Okay, Vita. Thank you.
Yes, ma'am.
Thank you, Pratram. Thank you, Varad. Now take next example. You are supposed to write all these things, huh, student? And please try to solve the similar example. Take any block diagram and try to reduce it. So next example, you are supposed to write Now solution for the same problem. Again, I have taken same problem by using SFG. बघा जमतंय का? Please write second numerical, second example. Draw the block diagram. Draw the same block diagram. And for same block diagram, draw the SFG. And please cross check it. Now see how many forward paths are there, how many loops are there. So there is only one forward path. Okay, starting from this point. Forward path फक्त एकच आहे मुलांनो या diagram मध्ये, right? So this is only one forward path with P1 is equal to transfer function 1 into G1 into G2 into G3. How many loops are there? बघा loops किती आहेत? आपल्या block diagram मध्ये 3 loops आहेत. The same thing I have shown over here. G2, G3, H2 with minus sign. कारण minus आहे feedback signal, right? Draw the block diagram again, then you will come to know. Then second loop is between G1 and G2 transfer function with positive sign and transfer function is H1. Third loop, जो bigger loop आहे तो third loop आहे बघा आपल्या diagram मध्ये. So I have replaced by SFG. Now this is nothing but third loop. Using G1, G2, G3 and feedback signal is minus. Okay, to RS. This is nothing but your summing point. This is summing point. This is also summing point. This is also summing point. Okay, and for this transfer function for feedback element we have taken as -1 because there is no any transfer function written in the feedback path. So you have to take 1 with minus sign. कारण minus आहे feedback signal sign minus आहे. So this is how you can draw the signal flow graph for given block diagram. So take the block diagram again, draw it, and this is nothing but solution for same problem by using signal flow graph. 2 loops, बघा loops कुठले कुठले आहेत. This is loop number 1. L1 म्हणते मी, L1. हा जो आहे हा आहे L2, and this one is nothing but L3. बरोबर? Now what is transfer function for L1? L1 is equal to G2, G3 into H2 minus sign आहे म्हणून L1 is equal to minus G2, G3 into H2. Okay. Now writing equation for second loop, L2. L2 is equal to G1, G2 into H1. Now transfer function for third loop. हा third loop आहे बघा L3. Loop 3. काय आहे ट्रान्सफर फंक्शन लूप 3 चं बघा. G1, G2, G3 into -1. So you can write L3 is equal to minus G1, G2 and G3. So you are having equation for loop 1, L1, equation for loop 2, L2, equation for loop 3, L3. बरोबर? 3 equation 3 loops चे आले तुम्हाला, right? Now there is only one forward path. Okay, P1, which is having, this is forward path P1. This is forward path P1 म्हणूया आपण याला. P1, only one forward path is there. P1 is equal to 1 into G1 into G2 into G3. Now you are having all these things. Now by using Mason's gain formula, you can calculate the transfer function for the given problem. करू शकता मुलांना?
मॅम एकदा हे लूप्स चे इक्वेशन एक्सप्लेन करा.
Loop चे equation. Okay बेटा, okay. हाँ. So this is my L1, loop 1. Loop 1 कुठून कुठे आहे दाखवते मी तुम्हाला. So this is nothing but my loop 1. हा जो आहे हा माझा loop 1 आहे, बरोबर? So L1 is equal to, in terms of transfer function of process and transfer function of feedback element. आता L1 जो loop आहे त्याचं ट्रान्सफर फंक्शन काय येणार आहे? G2, G3 into H2. H2 काय आहे? मायनस. मायनस का घेतलंय मुलांनो? Now observe the block diagram. So at this summing point, feedback signal is having minus sign. So that's why I have written this H2 with minus sign, right? Flow is in this direction. So L1
Yes,
is
ma'am.
equal to G2, G3 and H2 with minus sign. So L1 is equal to minus G2, G3, H2. Got it?
Yes, ma'am.
ओके बेटा. आता L2 चं इक्वेशन सांगते. आता लूप 2 आहे बघा. हा लूप 2 आहे आपला. ओके. Now what is the equation for L2? L2 is equal to G1, G2 into H1. बरोबर? Into H1. H1 पॉझिटिव्ह आहे. या समिंग पॉइंटला जो सिग्नल आला that is having positive sign. So H1 is positive. And hence you can write equation for loop 2. L2. Excuse me. You can write equation for L2 is equal to G1, G2 into H1. Now coming to third loop, L3. L3 बघा कुठे आहे माझा? Now this is nothing but my L3. सगळ्यात मोठा जो loop आहे that is L3. Okay. So how to write equation for L3? 1 into G1 into G2 into G3. Feedback elementचं transfer function काही आहे का? नाही. So according to rule, you have to take 1. H is equal to 1. But feedback element, feedback signal is having minus sign. या summing point ला जो feedback element आलेला आहे, that is having minus sign. That's why I have written over here minus 1. And hence the equation for loop 3, L3 is equal to G1, G2 into G3 with minus sign. So L3 is equal to minus G1, G2, G3. Got it? Got the answer?
Yes, ma'am.
Okay, beta. Thank you. Something is written in chat box. Let me see. Any question? Okay. Yes. Thank you, beta. Thank you. Ata. The same thing I have written in next. Now this is the forward path. Only one forward path. So P1 is equal to G1, G2, G3. Right? Now loops. Coming to loops. So L1 is equal to G1, G2, H1. L2 is equal to minus G2, G3, H2. And L3 is equal to minus G1, G2, G3. Now you are having all these terms. Right? L3 चं equation आहे. L3 is equal to minus G1, G2, G3. Okay. Now coming to the parameters that is used in Masson gain equation. So P1 is equal to this G1, G2, G3. L1 is equal to this equation. L2 is equal to this equation. L3 is equal to this equation, right? Del 1 is equal to 1. Only one forward path. Okay. Del is equal to, I have calculated this del. So del is equal to, yes, 1 minus into bracket L1 plus L2 plus L3 bracket complete. Okay. Now put all these equations in equation of transfer function. So G of S is equal to C of S divided by R of S. बरोबर ना? Just wait, some students are there in waiting room, admitting. Okay. So I have calculated del 1 minus into bracket L1 plus L2 plus L3 bracket complete. Now I have just to fill up the parameter, all these equation into equation of transfer function. So transfer function by using SFG, by using Masson's gain formula is equal to G1, G2, G3, that is forward path. Only one forward path is there. So I have written equation for forward path P1 is equal to G1, G2, G3 divided by 1 minus L1, L2, L3. बघा, L1, L2, L3, 1 minus L1 चं इक्वेशन काय आहे? G1, G2, H1. What is the equation for L2? L2 is equal to G2, G3, H2. What is the equation for L3? Minus minus become plus G1, G2, G3. Bracket complete. So this is nothing but your transfer function for given block diagram by using SFG. Got it? Any doubt up to this? Ata reverse. Okay, beta Anu. Okay, thank you, Anu. Now I am going to explain the same with reverse direction. आता SFG काढायचं आहे आपल्याला फ्रॉम गिवन ट्रान्सफर फंक्शन. आपण SFG वरनं काय केलंय? ट्रान्सफर फंक्शन फाइंड आउट केलंय, राइट? In the second example. Okay. Now the last one. Student, you are supposed to write all these things in your notebook. Now draw this. Next example, example 3. Transfer function is given and you are going to draw the signal flow graph. Just wait, माझं charger पूर्ण संपत आहे. Example number 3. Draw signal flow graph from given transfer function. Given transfer function is this. Transfer function is equal to C of S divided by R of S. C of S is output, R of S is input, is equal to 24 divided by S plus 2, S plus 3 into S plus 4. So at denominator we are having 3 terms. Numerator la only one constant. So 24 divided by S plus 2 is first term, S plus 3 second term, S plus 4 third term. So denominator में जो लिखा है, all these are poles. And numerator में जो होता है, if any one term is written over here, for example, S plus 2, that is nothing but zeros. These are poles. So this is the normal way to write transfer function. Okay. Generally, we are writing transfer function in this form. So this is the transfer function given. And you are supposed to write, you are supposed to draw the graph, signal flow graph for this given transfer function. So how many blocks are there? First one is having constant. This is nothing but again transfer function. Constant is transfer function. Okay. So I have taken how many blocks are used? 4 blocks are used. First block with transfer function is equal to 24. Second block with this transfer function 1 divided by S plus 2. Third block with this transfer function 1 divided by S plus 3. 1 divided by S plus 3. This is the transfer function of this block. Then last one is 1 divided by S plus 4. Now this is the transfer function of this block. Okay. Input is R of S. Output is C of S. So when you are talking about output, you have to talk about input X, or step म्हणूया आपण. This is X1 of S. This is X2 of S. This is X3 of S. That is input to next process block. This is input to next process block, right? So this is how you can draw the block diagram first from given transfer function. इथपर्यंत समजलं मुलांना?
Yes, ma'am.
Okay, Sushant. Now, see, I'm going to write transfer function of second block. I have taken 1 divided by S plus 2. So I can write in terms of 1 by S. The same term I can write by 1 by S. 1 by S ने numerator ला पण into केलंय आणि denominator ला पण into केलंय. So I can write this term like this. S raised to minus 1 divided by 1 plus 2 S raised to minus 1 bracket complete. Got it? Because the minimum transfer function for any branch you can write with 1 by S. And that's why I have adjusted my term. Within the second block, I have taken this transfer function, that is 1 divided by s plus 2. So I can write this 1 divided by s plus 2 like this. Is it same? S raised to minus 1, s raised to minus 1 cancel होणार. You will get only s plus 2. Right? बरोबर ना? Please simplify.
Yes.
Are you with me, students, up to this point?
Yes.
Yes,
Ma'am.
ma'am.
Okay. Now take the third box, third process box with transfer function 1 divided by s plus 3. So you can write this term as 1 divided by s plus 3 is equal to s raised to minus 1 divided by 1 plus 3 into s raised to minus 1. Got it? Simplify, you will get same term again. There is no any change in this term. When you are going to multiply with this s minus 1. S minus 1 means you are going to multiply with, yes, 1 by s. Here also multiply with 1 by s. So you can write this term 1 divided by s plus 3 is equal to s raised to minus 1. You are supposed to write, student, 1 divided by s plus 3 is equal to, एक term मी लिहून दाखवली इथे बघा. Second term you have to write, and from this term we are going to draw the SFG. Second term liha, 1 divided by s plus 3 is equal to s raised to minus 1 divided by 1 plus 3 into s raised to minus 1. Finish? Now, coming to last process block. Now this process block is having transfer function is equal to 1 divided by s plus 4, right? So I'm going to write this term 1 divided by s plus 4 is equal to, student, you are supposed to write 1 divided by s plus 4 is equal to s raised to minus 1 divided by bracket मध्ये लिहा 1 plus 4 s raised to minus 1. Simple. Got 3 equations for these 3 terms. For these 3 transfer functions, I have written in this form. Okay, this is again transfer function. Now you can draw the signal flow graph for this term. बरोबर? आता s raised to minus 1 means 1 by s. So these are 2 points, 2 nodes, you can say. This is nothing but branch connecting between these 2 nodes with transfer function, or you can say transmittance is equal to 1 by s. Now, as this is closed loop, okay, as this is closed loop, you can write, you can draw the branch from sink to source node, okay, with transfer function is equal to minus 2. minus 2 असेल तरच 1 plus येतो ना आपलं. So minus 2. So this is how you can draw the signal flow graph for this term, this equation. Got it?
Yes, ma'am.
Yes. Okay. Now coming to next. For this term, you have written equation is equal to. काय equation लिहिलंय वाचा बरं मुलांनो. What you have written for this term? 1 divided by s plus 3 is equal to, anybody from your side, what you have written?
S raised to minus 1 upon 1 plus 3 into s raised to minus 1.
Yes, very good. Now for that term only, you are going to draw the SFG. And that SFG is nothing but, these are 2 nodes. These are 2 nodes. With this is branch connecting between these 2 nodes. Okay. With transmittance 1 by s, right? And what is transfer function for feedback element is? Feedback element is moving from sink to source in this direction. With 3 is transfer function, that feedback element is having negative sign. So I have taken -3. Got it?
Yes, ma'am.
Okay, Sushant beta. Thank you. Now coming to third term, fourth process block, and third term is 1 divided by s plus 4. Now let me know, students, from your side, what you have written for this term in terms of s raised to -1. सांगा कोणी काय लिहिलंय? All should write. हाँ स्वराज बोल बेटा.
S raised to -1 divided by 1 plus 4 into S raised to -1.
Yes, very good. Thank you, beta. Now for that equation, we are going to draw the SFG. Baga. SFG. These are two nodes. Okay. These are two nodes. Source, sink. Branch is connecting between these two nodes with transmittance 1 by S. Okay. Feedback element is positive. Positive है कि negative है? Negative है feedback, right? या loop ला negative feedback आहे, right? So I have drawn the branch between sink and source node. Signal flow is from sink to source with transfer function 4. Feedback signal is having minus sign, so I have written -4. This is my 1 point, x1s. So between output and x1s, I have drawn one branch with transmittance 1 according to rule, according to steps given in SFG. Between these two nodes also, I have drawn one branch with transmittance 1. Between these two nodes also, I have drawn one branch with transmittance 1. Now, between input and summing point, I have drawn one branch with constant is equal to 24. That is given in this equation. So this is how you can draw the signal flow graph. Now, this is nothing but your signal flow graph. This total is nothing but your signal flow graph. Huh? This is the signal flow graph only for this term. ठीक है? या टर्म साठी फक्त मी एक एक्झाम्पल काढून दाखवलाय हा ब्लॉक. But for this equation, this is the signal flow graph. Okay, students, got it? नाही, मिक्स होतोय. छोटाच दाखवतोय. हा. एक मिनिट. मिक्स होतो. एवढंच दाखवू शकतो. किंवा एक गोष्ट करायला लागेल मला. Is it visible? Students, is it visible?
Yes, ma'am.
Yes, ma'am.
So for given transfer function, C of S divided by R of S, this is the transfer function equation, 24 divided by S plus 2, S plus 3, S plus 4. So you can draw the signal flow graph for this transfer function like this. Okay, so this is the signal flow graph. या ट्रान्सफर फंक्शनचा हा काय आहे? सिग्नल फ्लो ग्राफ आहे. You can draw like this. Understood?
Yes, ma'am.
Okay, Sushant. Thank you, students, for giving me feedback. So with this, unit 1 is
Ma'am, last slide
completed.
दाखवा ना.
हाँ बोल संस्कार. Any doubt?
Yes, ma'am. Ma'am, last slide दाखवा ना.
Last slide.
Yes, ma'am.
एकच मिनिट. Now this is the transfer function for this term only. ठीक है? And this is the transfer function for whole diagram. Okay. Save करते मी पुन्हा. हाँ कुठला स्लाइड दाखवू? लास्ट स्लाइड. दिस इज द लास्ट स्लाइड.
Yes, ma'am. Ma'am, याच्या
बस.
अगोदर.
याच्या अगोदरची. ओके. हा This one?
Yes, ma'am.
Okay. Is it visible clearly?
Yes, ma'am. Done.
Okay. Now this is the transfer function you have written from SFG by using Mason's gain formula. So students, today I have taken 3 examples. In first example, you have converted a complicated block diagram of control system into simpler one by using block diagram reduction techniques, right? In second example, I have taken again same block diagram and drawn the SFG. And from that SFG, we have calculated transfer function, okay, from signal flow graph. ब्लॉक डायग्राम वरून आपण काय केलंय, सिग्नल फ्लो ग्राफ काढला. सिग्नल फ्लो ग्राफ वरून आपण काय केलंय, फॉरवर्ड पाथ कॅल्क्युलेट केला. फॉरवर्ड पाथ वरून नंतर आपण काय केलंय, यू हॅव रिटन इक्वेशन फॉर L1, L2 and L3 लूप्स फाइंड आउट केले. यू हॅव रिटन इक्वेशन फॉर दॅट 3 लूप्स. ओके, देन आपण we have calculated del by using equation that is given in Mason-Gain formula. Del calculate केला. And just putting all these equation into that formula, we have calculated transfer function by using SFG. So this is what about second example. In third example, what you have done? You have drawn SFG from transfer function. So in that example, transfer function, equation of transfer function is given in terms of s plus 2, s plus 3, s plus 4, like that. Okay, and some constant is there in the equation. So what was the equation? 24 divided by s plus 2, s plus 3, s plus 4. So this is the equation given, equation of transfer function, and from that transfer function equation, you have drawn signal flow graph in the third example. Okay, so with this, unit 1 is completed. Any doubt? Thank you very much, students. If you have any doubt related to exercise related to block diagram, exercise that is helpful, we have to prepare the block diagram rules and exercise in the signal graph. That's it. The key is that you are used to start the examples. And when we get the exercise. Okay, understood? Okay, thank you, Dr. Manthan, thank you for your feedback. So students, voice is not clear, ma'am. Okay, ma'am, your voice is cracking. Okay, thank you, students. If you are having any doubt, you can ask me. Otherwise, you can write your roll number in chat box. I'm going to see now chat box. Any question is there? Please write with understanding. Please write your roll number with understanding in chat box. Kunal, Gokul. Please write with understanding. Please write your roll number with understanding. हाँ वैभव बोल बेटा.
मॅम या सब्जेक्टचे नोट्स वगैरे मॅम गुगल क्लासरूम वर कधी अपलोड कराल मॅम?
व्हिडिओ लेक्चर्स अपलोड केलेत मी सगळे.
ओके ओके मॅम नोट्स वगैरे
नोट्स एज सच काय हवंय तुम्हाला? नोट्स म्हणजे
मॅम लाईक पीपीटी.
अच्छा, पीपीटीज पण अपलोड केले, फक्त आजचा पीपीटी राहिलाय. फर्स्ट 2 PPTs I have uploaded already on Google Classroom.
मॅम असं टेक्स्टबुक टाईप वगैरे काही नाहीये का?
टेक्स्टबुक टाइप नाहीये, पीपीटीच आहेत माझ्याकडे. यू कॅन डाउनलोड दी टेक्स्टबुक फ्रॉम वेबसाईट. सॉफ्ट कॉपी असेल बघा टेक्स्टबुक किंवा रेफरन्स बुकची, सो यू कॅन डाउनलोड डायरेक्टली. Students, please write your roll number with understanding in chat box, please. Don't write only roll number. हाँ बोल.
तुम्ही आमच्या गुगल क्लासरूम वरती नाही अपलोड केलंय.